Hi, I'm Joe Hoffmaster, and today I'm here to explain the electrical systems on a Chaparral Signature Cruiser. This could apply to most boats. The actual switches and so forth may be a little different varying from boat to boat. Okay. On every cabin cruiser, just like any motorhome, you're going to have two systems. The first system is a household current system that works just like it does in your house. That operates on 110 volt AC. And you have another system that acts like a car that operates on 12 volt DC. So what happens on a boat is you have essentially a 12 volt car, and then you have whatever the car needs to do in order to generate that 12 volt power to operate most of the stuff on the boat. There are really only 3 or 4 things that operate on household current on a boat. One is the air conditioner, another is a stove, another is a microwave, most of the time the TV set, and the water heater. Although some water heaters also are connected to the engine, as is this boat, so that the engine can warm water that's in the tank. The umbilical that takes the household current to the boat is this, which is called a short cord. You won't see this on a house. That's because with a house, the wire is run underground through a pipe and then comes into the house to the electrical panel. On a boat, what happens is you have a removable cord, because the boat's going to move. It plugs into the back of the boat, and there's actually a breaker right there where it plugs in to the boat. And you always want to check that breaker. Make sure it's on, otherwise you won't get power into the boat. Alright, so now we're going to go into the boat. And we're going to follow the 110 volt power, which goes from that circuit breaker to this panel right here. This is the 120 volt or 110 volt AC panel for this boat. It indicates that we have 120 volts to the panel and that we have power from the short cord. If we didn't, either that breaker is popped, or there isn't power at the plug, or the plug isn't plugged in all the way. So that's kind of the knee bone connected to the leg bone of it. And then these are all of the things that operate on 110 volt power. Like the refrigerator operates on 110 volt and on regular battery current. The air conditioning, and so on and so forth. On a boat, what you tend to do is leave things off when you're not on the boat and turn them on when you get on the boat, which is kind of unlike your house. Although if you're smart and you're going to leave a house for a week, you might want to turn things like your air conditioning breaker off, so that you don't get them fried if there's an electrical storm or a power surge. Well, we do that on a boat all the time. Alright, so now, what operates on 12 volt on the boat? Well, that would be your cabin lights, your fresh water pump, your engines. There's a whole lot of things. Vents, fans, blowers, stuff like that. So what happens is there's actually a master switch. Just as there's a breaker where the short cord plugs in, there's also a master switch between the batteries and the panel. Okay, now I'll demonstrate that. You're going to have 3 battery switches on a Chaparral. This could vary if you had a Sea Ray or something else, but on a Chaparral, what you're going to have is this panel here. Now this is your master breaker panel for the DC side. If the boat were completely dead on 12 volt power and you wanted to start the motor or lift the engine hatch, you could actually hook a booster pack to this, or a pair of jumper cables, and hook them to another battery and lift the hatch up. Anyway, so this is really simple. The port battery operates the port motor. The starboard battery operates the starboard motor, and the house battery operates everything else. So for things to work, the house battery has to be on. That then will send power to that panel. Okay? This panel relates to mostly what's happening up on this dash, and a couple of other very important things. That panel operates things that are down in the cabin, and accessories such as cockpit refrigerators, etc., etc. So let's go now to this panel. So now we have a 120 volt panel. Power is here. Battery charger is on. Now this battery charger's function is to convert 120 volt power to 12 volt power. And that's important because if you don't have this on and you turn on your cabin lights, well, let's see. Yeah, you turn on your cabin lights and you leave them on for a week, it'll run the battery down because there's nothing charging it. So you always want to have that battery charger on. Really, in modern days, you can leave it on 100% of the time. But at the very least, you want to have it on when you're on the boat so that you run things like the stereo and the household lights, you don't run the house battery down. Okay? So now, the next question is, what happens if I'm away from the dock? Well, if you don't have a generator, you don't have 110 volt power, so you must run the engines in order to get your 12 volt batteries charged. The alternators on the engines will do a wonderful job of that. If you do have a generator, you then have the ability to start your generator and run your 110 volt accessories, including your battery charger, when you're away from the pier. To do that, you have to flip a switch to change from shore power to generator power. If you don't do that, they both feed together and make 220 volts and blow everything up in the boat. Fortunately, Chaparral follows ABYC code, so it's impossible for you to have the boat on shore power and generator power at the same time. If we want to do generator power, here's how we do it. Number one, we turn the shore power breaker off. Number two, we start the generator. Now, you'll notice there's a blower switch. That's because the generator is an engine, and like any other engine, it doesn't do well if gas fumes are present. So you want to run a blower before you run your generator. It's a very important thing to remember to never start a generator under load. So you'll notice my method here, turn the shore power off, start the generator, then slide over to generator power, then power up the gen using the master breaker. I will demonstrate now. Now, they start differently depending on the year. It used to be you held the button down. Alright, so you hold the button down and then the generator starts up. You hear it? Now, it's making a certain noise right now. It should quiet down in a couple of moments. Not by a lot, but by some. There. If you were to look outside right now, which I recommend, you will verify that the generator is pumping water. Everything in a boat is cooled by river water. So you start the generator, you want to make sure it's pumping water overboard. If you start the air conditioner is a heat pump that is cooled using river water. You need to look over the side of the boat and make sure that the air conditioner is pumping water. It's hard to tell if the engines are pumping water because they're stern drives. You have to watch the temperature gauge. Just make sure it doesn't go over 160 degrees or roughly so. Alright, now that we know our generator is operating, we'll come back to our panel and we'll slide our power from gen to shore. Note our gen light here. It means we have power here. If we hit this breaker, we should have 120 volts here. And we do. Now that we have 120 volts, we can operate anything on the boat that we want to. Microwave, stove, etc., etc. Now, there's a maximum number of amps that a generator will let you use. Like if it's a 5,000 kW, it's a 5 kW generator, that's 5,000 watts divided by 120 volts. It means you can't use more than about 40 amps. There shouldn't be more than 40 amps worth of stuff on here to run, but that's why you have an amp meter that shows what your draw is. If you'll notice right now, with the microwave, the battery charger, and the stove on, I'm drawing about 6 amps. If I turn my air conditioner on, which better hit the air conditioning breaker first before I do that, if I turn my air conditioner on, it's in test mode. Let it do its thing. Now it's cycling and it's kicking on. and you can tell at some point the compressor kicks on, which it just did. Now we've peaked at about 25 amps and came back down to about 12, 13 amps. All right, now we're going to go ahead and turn our generator off. Maybe we're done using our stuff or whatever. What you do is you turn your air conditioner off and you turn off anything else that you had on. You turn the generator breaker off so that it doesn't have a load on it, and you hit the stop button. And the generator quits, and then you turn the blower off, and then you slide the shore power selector over, and you change the breaker on the shore power to on, and you have 120 volts at the panel again. I'm sure you'll be replaying this a few times, but that is everything there is to know.